All right, enjoying the conference so far? Wow, that's loud. Let's fix that a little bit. Okay, it's a little better. How are you enjoying the conference so far? Excellent. Oh, good. That's a lot of enthusiasm. My name is Spencer, and I'm here to talk to you today about using immutable data structures in C# and .NET in general, especially any VB.NET users out there. Anybody? You're out there. Okay. All right. You're just like web forms users. You just don't like to talk about it, right? So this is my second year coming to DevConf. I'm super thrilled to be here in front of you to talk to you today. So my goal is to sell you the benefits of immutability in C# and VB.NET. Kind of give you a little bit of the functional perspective, but without all the baggage that functional programming comes with. Anybody here consider themselves functional developers using Haskell or something really functional, F#? Okay, cool. All right, so then the jokes that I make won't offend most of the audience. Okay, so if you talk to people who do functional programming, you might see a little bit of code like this, where you're just creating a new person, and they might be looking over your shoulder looking at this, and you might say, okay, well, there's a new person, and maybe we want to set their first name, just give them a first name, right? Use mutability, use those getters and setters like they were meant to be used, those properties, right? And then you might want to set a last name. And the functional person's looking over your shoulder, and they say something like, oh, man, you're mutating state. Don't do that, right? And how useful is that, right? They just say, you're changing data right there. Don't do that. And then they say, what are you supposed to do? You just comment out the code and just walk away? Yeah, I guess that's it. And then they say, yeah, don't do that. Do you have any questions? And they kind of drop their microphone and walk away, right? And then your reaction to that, to hear something like that, is to say, don't tell me what to do. I mean, this has worked for me for years, right? This has worked for me for years. Why should I change anything about what I'm doing, right? And that's kind of one of the pillars of functional programming is immutability. It's a very strong one, right? It's one of the things that they say, don't change the data. But it goes back to the kind of almost, I don't know how to say, I don't know, that feedback isn't very useful. And yes, I've had people tell me that functional programmers do tell them to do things like this, which leads me to a question I have for you. How do you know that somebody does functional programming? It's kind of like when they do a new diet, they won't shut up about it. They'll tell you. Functional programming. So there's a lot of things that we can learn from functional programming. And we can do it as I mentioned, in a pragmatic way. We can do it in C# and VB.NET. In a way that sort of makes sense for the language, even if it's not something that it was originally designed to do. And one of those things, of course, you know that this is the subject of the talk, immutability. Immutability is possibly the strongest. There's actually two that we're going to talk about. And so what I'm going to show you is some examples of some code where mutability specifically breaks things, and how immutability, sprinkling it into your code, can help you. I have to warn you, though, there are a lot of bad immutability jokes in this slide deck, which just goes to show you that some things really do never change. All right, so anybody ever done something like this, where you go to a development shop and you're really wanting to impress, you're really wanting to make a good first impression. So they feed you small feature requests, they give you little things to do, and you say to yourself, oh, I can do this quickly. It's just a small change here and there inside of this code. Maybe it's a web application and they want to change something to display red instead. So you go in and you make that change, and you don't really test it. You just kind of push it out there. You probably test it for the first time, but you get a little more confident, a little more cocky, right? And you start making these incremental changes without really doing any of the due diligence, right? And you're just trying to impress the boss. It took you 5 minutes to do. It took you maybe 30 minutes to look through the code, 5 minutes to do it. This is what I call programming by hope. And then I hope I don't break something. I hope I don't break something by pushing out the change that I've just pushed out. And unfortunately, C# and VB.NET from the beginning have sort of encouraged some bad habits, right? Let me ask if anybody's done like this. And yes, this is based on a real example. So I'm going to give you an example in web forms, because I actually love web forms. It's kind of like Stockholm Syndrome. I love it even though it hurts me, right? I still have clients that use web forms. Anybody current web forms developers? Okay, past? Right on. Past web forms. Okay, so this is a pretty relatable example, and it really does translate well to MVC. So, but we've all done something like this at some point, where you've got your page load event, and you're trying to, and all you want to do is get from a repo somewhere, get some orders. Maybe you're an order website or a website that's displaying some kind of order for customers, and then you assign it to a data grid, and then you call data bind. Right? That's a pretty common thing. And then the feature requests start rolling in. Maybe it's the incremental changes that I talked about. Maybe it's something that you've been asked to do, and I know that I need to change this particular request. I need to change it on this page. It should be no problem, right? So the feature request is that order amounts that are negative should have a red name. All right. So then you start doing something like this. You create a separate method because, you want it to sort of describe what your method is doing, right? Add red. So you iterate through each of those orders, and you say, if order amount is less than 0, you go ahead and just change that name. You don't necessarily, even though it's probably better to put that on the front end, you just go ahead and throw it in there because, hey, you're wanting to make an impression. And at the end of the day, this technically does meet the requirement. Raise your hand if you've written something like this at some point in your life. Yes. Okay. Those are the honest people. The rest of you are lying. So you get that, and that's not a very unreasonable request to fulfill, and it's certainly not the worst refactor I've ever seen to meet a requirement. But then the feature requests, again, they just keep rolling in. So salespeople who are not active should not be displayed. So essentially, if they've got an order and it's a salesperson attached to them, if they're not active, maybe they were fired, maybe they quit. They're just no longer part of the company. So we're just going to pretend like they never existed. So you do something like this. You break it out into a separate method. You iterate through each of those orders. And you say if the salesperson is not active, just go ahead and set them to null. They never existed, right? So then they won't display on the page. All right. So now this is what your page load method looks like. Again, you've taken your orders. You've gotten it from your repo. You've added red. You've displayed only active salespeople. So far, you've done your job well, and you haven't introduced any particular bugs, just opportunities for bugs, right? So then you have a method that comes in and says, well, we need to calculate commission. And if the person is a salesperson of the month, their commission actually gets multiplied by 2. So then you do something like this, right? You go through, you iterate through the orders. And if the salesperson is the employee of the month, you set their commission to times 2. And then you put it in your page load method. And of course, this is the part where this is where it blows up, right? Because the calculate commission requires a salesperson. And this is what happens at runtime, right? As soon as you get an inactive salesperson, the whole world blows up, right? And then you get null reference exception. Everybody's least favorite exception because it's an important one, but it's the most vague, right? You got a null reference exception because you mutated your data, because you mutated the data, because the data would allowed it to be mutated. And again, you're just trying to get stuff done, right? That's our jobs, is to get stuff done. You're trying to make a good impression. You ran through each of the requirements, but you did something like this. You mutated your data, among other things like mixing your data and your view stuff, right? And this is not an uncommon thing. We've all written code like this. This is not really that unusual. But what we've done, because it was so tempting to just mutate that order in place, we've left those setters open. We've allowed the orders to be mutated. We've introduced bugs. Essentially, in my opinion, that if you have an open setter on a property, and you pass an object to a method, you're basically inviting that method to change the data when it suits that method, right? You've sacrificed your ease of change versus your safety. You've made ease of change. Your change is very easy to make, right, with immutability, but you've sacrificed safety to do it. And I would argue that you really haven't made you haven't gained anything. It's not really an ease of change. It's just super convenient because as .NET developers, we're used to mutating data. That's kind of what we do, right? That's just part of the language. So you may know this guy, Scott Hanselman. He complains often on Twitter that because he tweets a lot, and occasionally he'll send out a tweet with a typo. And it'll say something like, I see you taking pictures. Please don't tweet at him that I'm talking about him right now. No, I'm just kidding. All right. So occasionally he'll tweet out something with a typo, and he'll say, damn it, I need an edit button. You and autocomplete suck. And he sends tweets like this out all the time. Okay, well, conceptually speaking, if you tweet a lot, an edit button doesn't seem like an unreasonable thing to ask for, right? But this is where it gets complicated, right? So let's say this is a recent tweet by our friend Elon Musk. who's being investigated now by one of my government bodies for some kind of securities fraud. That should be interesting, right? But he still tweets a lot. And this is one of the tweets that he sent out. Defeating traffic is the ultimate boss battle. I was talking to an attendee at the conference yesterday that said that that traffic here in Poland can be kind of bad. And in St. Louis, Missouri, where I'm from, which is basically the middle of nowhere, it's not horrible. So I assume that if you defeated traffic one way or the other, if you used a helicopter, it is really beating the ultimate boss. So you say, this is a reasonable tweet, so I'm going to go ahead and retweet it, right? Flip that from not green to green. All right, cool, I've retweeted it. And that's great. But let's say there was an edit button on Twitter. Let's say that Elon Musk, after 13,000 retweets, 100,000 likes, has decided, you know what, I didn't really like the original message of the tweet. This is really what I meant, which is that if you agree with what Donald Trump says 100% of the time, go ahead and retweet this. Now, tell me, what have you done? You've changed the intent of the original tweet. I didn't retweet this. I didn't retweet that. I retweeted this, right? So that's where the edit button comes in. That's where the edit button comes in as introducing problems, right? John Carmack famously said, a large fraction of the flaws in software development are due to programmers not fully understanding all the possible states their code may execute in. And the edit button is a perfect example of why mutability is bad, is a bad thing. Because as soon as you add a tweet and as soon as you add a feature for an edit button, now you have to ask yourself a lot of questions. What if it's been retweeted? Do I just cancel all the retweets? What if it's been liked or quoted? And maybe does the date timestamp get reset, right? Now you start to have to do all of this reasoning about your code and all the different states that your code is executing in. Whereas if you just don't give them an edit button, you don't have to worry about any of that. You don't have to worry about mutability or the effects of mutability because tweets are immutable. And believe me, I am huge of the opinion that tweets should be immutable. Otherwise, you run into problems like that. And you really, again, it's all about reasoning. I don't consider myself to be like a super smart person. I don't like to think too much about my code. If I can make things immutable, then that means I don't have to worry about what if somebody changes this variable down the road, right? What if they change the meaning of what if they change this? Does it change the meaning of the code? Does it change the meaning of the object? I don't have to worry about any of that if I close my setters and make things immutable. Let's talk about methods that look like this. Something that takes in a list, right? Again, going back to that point that I made earlier of when you have a method like this that takes in a list, and when we're fairly novice .NET developers, calling toList on just about everything, because list is super flexible and awesome, right? Calling toList on everything is very tempting, and a lot of .NET developers do it. But when you have a method like this, you're basically asking the method to mutate that list, right? Why are we not taking in IEnumerable of string? Should I be able to add to this list? Should I be able to remove elements from this list? Right? The method isn't really telling you. The method is taking in a list. It's taking in a list, so it's inviting it to be mutated, right? That's basically telling that method, I don't know what's going to happen on the other side of this, right? I don't know the state. I don't know what to expect the state of this object to be. Again, it goes back to reasoning. Then you have to think about it, and then you have to dig through the code. You have to see, does it mutate the list or not? Whereas if you had used something like IEnumerable instead, you probably could have avoided that. Let's talk about multi-threaded data. How many people work in heavily multi-threaded applications? Okay, a fair amount of you. There's a guy named Kevlin Henney, and he does a great talk called Refactoring Towards Immutability. Which is where the genesis of the idea of this talk came from. He's very philosophical about the idea of immutability, and I would highly encourage you to watch that talk. It's on YouTube. But he shares this picture, which he calls I don't remember what he talks about, but what he calls this thing. But essentially, it's the two axes of the different states of data. So if data is shared or multi-threaded versus unshared, and whether it's mutable or immutable. And he talks about this particular one, where he says that this is the danger zone. This is where data is not only shared amongst multiple threads, but it's also mutable. And therefore requires synchronization. You have to synchronize. You have to bring all of the data in line in order to do processing on it. If you're able to change the data in one thread, the other thread needs to know about that, right? It increases a huge amount of it increases the danger of your multi-threaded code by a lot. And I would tend to argue that I avoid all that by just treating mutability. I think this is bad too. So I treat most data as immutable because I don't want to have to even think about the top right quadrant, right? I think both states are bad. I think mutable data in many places is bad and unnecessary. So, since this is a C# talk, we're going to talk about the history, a little bit of immutability in C#. And I'm going to demonstrate that we've been using immutability for a long time in one construct or another. A lot of that has just been hidden away by the language. Let's talk about string and datetime and number types, right? These are types that have been around since the beginning. And they have been immutable since the beginning as well. When we're a new .NET developer, of course, at some point we've probably done something like this, where we have a string, we call .replace on it, and then we write it to the console or display it on a web page. And then we kind of look at it and wonder, why didn't it change? Because the output of this code would be replaceable with a question mark, right? If we wanted to replace the question mark with the exclamation point, we're not doing that in this code because string.replace returns a new instance of string, right? That's immutability baked into the language and is baked in since the very beginning. Same thing with the DateTime object. And we've all, at some point in our novice years, we've done something like this as well, where we just said, oh, if we just call on now, if we just call .addHours, we will get back, or we won't get back a new object. It'll just mutate the existing object in place. When in reality, of course, we know that after a while we figure out that same thing with string, that's not how that works, right? And that's a good thing. It returns a new instance of datetime. Imagine if you were able to call addHours on the datetime.now and just start mutating that state in time. Kind of like in JavaScript, how you used to be able to overwrite the value of undefined, which is a real thing. You used to be able to set undefined to something else, right? That would be terrible. We wouldn't want to do that. Let's talk about C# classes, right? So the immutability has taken many forms in C#. And it started out looking something like this. It didn't look exactly ideal, right? This was kind of messy code, but this is technically immutable, where you'd set your, in your constructor, you'd set your first name property to a first name field, right? And then you would just create a get-only property that then returned that field. This does the job. This gives you immutability, but it's very ugly, right? It's a lot of lines of code just to express one thing, it's a lot of lines of code to just express one thing, which is that I just don't want to change the value of this once it gets the job done, but it doesn't look nice. Then, of course, we got auto properties, which are really convenient. But in order to use auto properties and immutability, we kind of had to cheat a little bit. We had to make the setters private, which means that technically the object could still mutate the data, even though outside objects couldn't, which is a step in the right direction. So we've got cleaner code in exchange for a little less safety, but at least the code is cleaner, right? So 5 private get or read-only fields, they both got the job done at one time or another. But they never really solved the problem very well, right? One was really ugly, but got the job done completely. The other one was less ugly, but didn't truly close the gap on immutability in C#. And then, of course, C#6 came along and had a moment, right, where the angels came down from heaven and said, you know what, we're going to go ahead. And I was actually really surprised that they did this. It felt like it could have been a breaking change, but I suppose it was not, because this is what we got in the end. This is so much nicer and so much better, where we just give in our first name and our last name, set them to the properties, and then close the getter and close the setter, such that you can't there is no setter on this, so you can't use reflection to override it, and you know that the method itself, the class itself can't then further mutate that data. So this was probably immutability perfection as far as we will get in C#. So, talking about immutability today, again, we've been using immutability inside of C# for a very long time, right? We've just maybe not known about it. LINQ is another great example of something that used functional immutable concepts in order to improve the language, right? LINQ has made us so much more productive as .NET developers. And yet, what they did was all they did was button on existing functional features onto an already great language, right? The best example of that being anonymous types. Anonymous types is possibly one of the most well-designed language features in C#. It has a lot of great advantages. And we've all used anonymous types one time or another, because at the end of the day, I don't want to declare classes for every possible data shape. Sometimes I'm just trying to get stuff done, right? It's ideal to have an entity class, right, translate to a view class of some kind. But back in my earlier days, I didn't really enforce that well, and anonymous types really helped bridge that gap, and they're super useful anyways. This is an example of a projection, right? So this is taking the employee's object and just selecting some data from it based on, well, you give it a function, and of course it returns that new data, and it gives you an anonymous, what's called an anonymous type. This is nothing new to most, for pretty much any of us. But anonymous types have a lot of good advantages that we should really study and hone in on a little bit. First, anonymous types are immutable by nature. You cannot change the data once it's been assigned to an anonymous type. They also have structural equality unless you're using VB.NET. And maybe one of the worst design decisions was not adding structural equality to anonymous types in VB.NET. You have to opt into it. But besides that, anonymous types, an amazing example of immutability added later into the language in a way that really made sense for the language. So you can't do anything with this, and that's awesome. You can unwrap it, right? You can display this data on a web page. You can't change it, which is awesome. Imagine if you could go through your get orders, and then you started spinning through anonymous types, and then you called toList, and then you were iterating through to mutate them, right? All you're doing is adding more opportunities for bugs. But C# did something which I think was incredible. And we can learn a lot from anonymous types. Linked methods themselves, again, great examples of immutability introduced to the language in a really kind of subtle way. Again, string, DateTime, always been immutable. Numbers, always been immutable. Linked methods, though, have always been immutable as well, at least unless you mutate inside of like a select method or a where method, which, ugh. But if you don't do that, if you just call where select and you treat them as pure, they don't mutate the data either. They don't mutate the collection, and they certainly don't mutate the data inside of the collection. So if you did something like this, you got your employees, and then you spun through and you did a where clause where you wanted all employees that started with S and select and project it down to an anonymous type that contains the data that you want, right? Subtle difference is I'm calling it right here. But if you're using, how many people use ReSharper? How many people use ReSharper? I love that. I love to see all those hands go up. So when you see something like this, ReSharper is going to squiggly underline it and say return value of pure method is not used. Again, they're not modifying the original collection. All they're doing is allowing you to operate on that collection without modifying the original collection itself, which is awesome and gets us to the concept of projection. This is, when you look at it, you might say, Spencer, this is so obvious. But to some people, it's really about articulating the difference between mutation, the power of mutation, and the power of projection. Changing that mindset in your head where you just basically stop and think to yourself, how can I, instead of mutating this data to get what I want, take this set of data and project it to something else that I need? And now you can turn it, after watching this talk, or maybe not, maybe you have words, maybe you have better words to articulate to junior developers or other developers, the power of projection over mutability. Right? And this is pretty much, link is projection. The select method is projection. It allows you to project employees from something to something else, which is really powerful. Because again, you're not modifying the original collection, and you're also not mutating any data to get it to the shape of the data that you want. I'll give you an example that was a teaching moment for me in my career. So I have a mid-level developer who saw this column. So back at my company, we are very big into taking classes of data and being able to interrogate entity framework to get column names and column information, such that we can do some cool operations on that data, or on that using that metadata from the database. So we could get a person class, right, and get a whole bunch of information about that person. So we have this interface called iColumn, which takes a column name, which just describes a column in a table in a database, and it has a column name and a column type. And then, of course, it has a concrete implementation of column name, column type. Pretty standard so far. It has a lot more stuff, but I'm shortening it out for brevity. And here's how something like that might look. let's say that we were trying to describe the person table, right? And it has a first name and a last name and an age and an ID that's a GUID, right? And so we want to do something with that metadata. We want to be able to say, well, we want to print the columns. We want to print the names of all the columns, or we want to print the type as well. It doesn't really matter. We just need this metadata to do some kind of operation. So we go through and we say get columns for table, right? So this was great. This was code that I feel like was well written. The method actually doesn't look like this. You're actually interrogating a database. Again, just for example. But this was well-written code. From my perspective, they closed all their setters. They didn't do anything right, because in the end of the day, you shouldn't be able to change the description of a table. But there was a requirement that we needed to, anytime there was a GUID field, we needed to instead treat it like a string. We needed to instead treat it like it had the type of a string. Okay, well, so what this junior developer went in and took this beautiful interface, which just described that I'm describing a column, but I'm not describing that I can change that column later. And he added a setter to it. All right, so he went in, he's like, well, I need to be able to say if it's a GUID, make it a string type instead. So he added the setter, he changed the column concrete class, and we ended up with code that looked something like this. Now, in and of itself, this is not horrible code, and I believe the pull request was actually submitted and actually passed by another developer, and I kind of let this one go, but I use it as a teaching moment. I said, think about the state. Went to that programmer and I said, let's think about what we've done here, right? We've taken something that describes a column and we've mutated it, but there was really no reason to mutate it. There was really no reason to add in mutability, not when we have projection, right? Again, looking at this interface, I have to go back and think about this. Is this I column meant to allow me to mutate that column later? Or were they just were they adding this setter just to get around some other kind of lack of behavior, right? Or maybe they just didn't know better. They did something like this. And then developers have to do this, right? They have to reason. They have to really think about the stuff that they're doing. They have to look at the code and really think, what was the intent of this? And again, it goes back to this concept of passing around mutable data. You're basically, when you pass around mutable data to methods, you're basically giving that method, that thing that you're calling, the permission to mutate it down the road. So I use this as a teaching moment. I said, instead of thinking about how can we change the data, how can we project the data? How can we take this data and create new data from it such that we can operate on it but not have an open setter? Again, in and of itself, that code in a nutshell, not terrible. But it was more powerful a lesson. It was much more powerful as a lesson, a teachable moment. Whereas I just showed him instead of going through and iterating through and mutating that in place, why don't we just do something like this? Use our select, use link. We use link every day. Why not use it to then say, well, if we have a column where of type of GUID, make it a type of string instead. So the developer took this away, agreed that this was a change, agreed with the concept, right? He was a little bit defensive at first, but he ultimately got that introducing mutability unnecessarily forces developers to really think about, again, like John Carmack said, the state of their code. Or what John Carmack said is not really understanding the state of the code that can execute it. Again, small example, but big implications. Now the developer, sold on the concept of projection, writes code more like this instead. So let's talk about other things. So we have link. We've had link forever. So let's talk about systems.collection.immutable. Now, if you're using a lot of modern libraries, and pretty much everything in .NET Core, and many of the NuGet packages will give you a reference to this automatically. So let's take, since developers seem to love lists, let's talk about immutable list, right? Immutable list being an example of a great little interface that allows you to, if you passed an immutable list to something else, perhaps you want them to be able to add elements to it, but not actually mutate the original list. So we get something like this. This is what the code would look like. Immutable list.create, and we give it a string just to start it off, right? And we say list.add, and we set it to the value of a second list. And then we write the names of the first list and the second list. And then we compare the hash codes of the two lists. And if I ran this code inside of a browser or something else, or Visual Studio Code, this is what it would output. Probably nothing really surprising. The original list did not change at all. What the add method did instead of mutating that list in place, it actually returned a new list with that second element. If you've done lists in F#, this is much more akin to how F# treats lists, right? They treat them as mutable and allow you to mutate them by returning new lists, right? And there's not a lot of overhead involved in returning a new list. You still have, if you're using reference types, it's still pointing to the same reference. It's not duplicating that. It's creating a tiny, tiny, tiny amount of overhead in order to create a second list. But what you've gained instead, the huge gain that you get, is the guarantee that your list is not any different. The original list that you've passed into this method is no different than the one that is no different at the end, right? That allows you to reason less about your code, right? You want to reason about your code, but you don't want to reason too much. At least I don't. So let's talk about library support. So let's be honest. C# is a mutable language. It was designed with mutability in mind. .NET was a mutable first ecosystem from the get-go. So what about our favorite libraries, right? Do they have good support for immutable objects? And the good news is that they do. So let's take a couple of examples. AutoMapper being the first. So if we wanted to say, oh, no, you can see that. Yes. So if we have an employee object and we want to map them to a generic person, right? This is just like this tiniest, littlest use case. But we do this. How many people use AutoMapper? Lots of people. Okay. If you don't, definitely look into it. It certainly makes my life easier. So when we create a mapping between a person and an employee, so we want to create a person from an employee, we might write code that looks a little bit like this, except maybe they just have open setters and it's just for the convenience of the developer. They just have the person object have an open setter and pretty much look almost exactly like an employee. Well, the good news is that even though you're not necessarily describing inside of your mapping code how to map an employee to a person, it doesn't matter because AutoMapper will take these property names here and map them by convention to these property names here, right? So the property inside the employee first name property will get mapped to the first name property or the first name parameter inside of your person constructor. And AutoMapper does that automatically for you, right? There's no thought involved in it. It just does it by convention, which is really convenient. And of course, if you don't have the ability or you need to use a specific constructor, or maybe the variable names are different and they can't map by convention, when you create your mapping code, you can always use the construct using, right? So that's pretty strong. AutoMapper has its support right out of the box. Let's talk about Newtonsoft.json. If I asked how many people use Newtonsoft.json, an awful lot of hands would go up, probably all of them. Anybody who uses .NET probably used Newtonsoft.json, which is an excellent library. So what happens if you run code like this, right? We're used to just taking that those C# classes and just deserializing and applying the setters and applying those JSON properties directly to the setters. That was what Newtonsoft.json was designed to do from the get-go. Well, the good news is, again, mapping by convention that this code will work just like this out of the box. And if it doesn't, so again, mapping this first name property up to this first name parameter in the constructor. So you've got that library support, right? You've got that library support from AutoMapper, Newtonsoft.json. If you don't have, if you have another constructor or you need to deserialize, you have to pick one that the Newtonsoft.json library would then use to deserialize that object if you had to pick from multiple constructors. So that's good news. A lot of library support all around for immutability, at least in these two major libraries, right? So beyond libraries, though, there are a couple of patterns that you should be aware of that will allow you to add immutability to your code, again, in a very pragmatic way. If you've got AutoMapper support, Newtonsoft.json support, and support from maybe a few other libraries, immutability becomes a really easy thing to implement. But there are some things that you can do to take advantages of mutability and immutability. I really like the builder pattern, for example. The builder pattern is used an awful lot inside of especially ASP.NET Core, when you're configuring your services or configuring or using, or if you call .use to add a service to dependency injection pipeline, and it takes a config builder, an action, a method that will allow you to mutate what's called a builder object. And the idea is that you can use a builder to then return something that is immutable, but that represents the actual thing that you're trying to do. So let me walk you through an example. So this is a perfect example, and one that's used a lot in Entity Framework, is the DB context options builder. So in Entity Framework Core, your best bet when you're using Entity Framework is to pass in a DB context options inside of your DB context constructor. So what you do is you have this thing that is a options builder. It has its open setters, so you can change them, right? You can change that data to set a connection string or use a connection pool or whatever myriad other options that your DB context can have. And then it provides a method called build, which essentially just constructs a DB context options that's immutable, right? This is the builder pattern. And this is what it would look like in use, right? In ASP.NET Core, this is how you would use it. If you were constructing your application and adding those services to your dependency injection pipeline, you could call use.dbcontext, pass in a method that allows you to mutate an options builder. And then what it does under the hood is it returns an options that then can't be mutated later. So now you've got a DB context options that not even DB context can alter. And it can't alter it because it doesn't have open setters, which is good, right? The DB context options, once you've set them, it's not like DB context should in the middle of an execution decide, you know what, I want to change this connection string to something else. I think that'd be kind of horrible. But the builder pattern is really powerful because it allows you to get around that. It allows you to use the best of both worlds. It allows you to use mutability in a really safe way whilst then use mutability in a really safe way during the building while using immutability at the other end to ensure that the object that's actually used, the actual money object, then doesn't mutate state or doesn't get mutated later. How many people have seen something like this or written something like this? Maybe you're getting a service, and then before that service is called, for whatever reason, the developer, inside of your constructor, you shouldn't do a whole ton of logic. You should use property getters, property setters. You should check for null, those kinds of things. You shouldn't do database calls. So, you as a developer or a junior developer under you or really anybody says, I can get around that by using a setup method or an init method. How many people have seen or written code like this? It's fine. I've written code like this too, right? Back in the day. Where I have a service and I call init, and then I say, okay, before I do anything, I have to call init, and then I have to do something else. But it goes back to that reasoning picture that I showed you, right? It goes back to that where you have to then think like, well, if I have this service, do I initialize it right away? What's the impact of not initializing it? Can I initialize it multiple times? Will that break things, right? These are things that you have to question. Whereas a more powerful pattern for kind of representing this thing, this behavior, is using a factory pattern, right? Where you get a service factory, and then you have a method that allows you to create that service and then allows you to do something. So leave the factory to then mutate or give the object all the data that it needs to run, and leave the service to be immutable. Here's an example of a service that I think is pretty good. Again, closed setters, so you can't alter the setters later. They can't alter themselves, and it takes all the services that it needs to execute. This is the kind of code that I see written, and the kind of code that I write at my own company, where a service just does one thing or does something really well, and it takes all the services that it needs, and then it can't change them later. Some of the pull requests I reject are from developers who are really junior, or $10 an hour developers from wherever, where we go in and they start adding services that are mutated, and then as they need to have those services be, if they add a service to this order service, right, a third property, and they don't want to change the constructor, so they go in and they put in an auto property with an open setter, and then they just set it after construction in one place, and then they use it the rest of the time. That's terrible, because it's terrible for another developer who has to come in and use that. I don't want a developer personally, and I don't want a developer to have to know that I have to set that explicitly. Do it in the constructor first, so that way you don't have to worry about, do it in the constructor so you don't have to worry later about, is this thing null, is it not null? And it gets even better when you do something like this, right? This is even better code. This is taking your service and then now guaranteeing that the services that you pass into it, the things that you pass into the constructor, will never be null, right? So you avoid that null reference exception. Yes, you get argument null exception, but it's a lot easier to solve for this, and you can catch this a lot sooner inside of your tests and inside of QA, much easier than you can catch null reference exception, at least in practice. And that's a really nice thing. So you can apply that logic to your person class as well. Or you do the same thing, right? You can give your person enough data. You can give that person enough data to then be set and then make sure that it's never null in the future, right? You can do that. You could do that here. So there's a spectrum, right? There's an appropriate amount of this. I definitely recommend it inside of your services. This is a little more questionable. Maybe a null first name is valid. It's really up to the business requirements, right? But you could do this everywhere and really avoid null reference exception, which I know is like, again, functional programming, right? They always avoid null and they always want your data to be immutable. But those are really powerful concepts. And it gives you a real 1-2 punch where you get at compile time, you get some guarantees of immutability, and at runtime, you guarantee that you can avoid null reference exception in a lot of cases. It saves a lot of bugs. It absolutely saves a lot of bugs. But, okay, we've talked about immutability, we've talked about avoiding null. Obviously, null is a first-class citizen in C#. There's a sort of a yin and yang, right? There's a good part. For every bitter comes the sweet. Immutability is not a one-size-fits-all answer. It just doesn't work in every aspect of the framework or in every aspect of C#. A lot of C# was built with the guarantee that immutability is just the way that you get things done. So if I went and told my team that we're going to make everything immutable, this would be their reaction. They want to kill me. That doesn't make any sense, though. It doesn't make any sense. C# wasn't meant to be a purely immutable language from the get-go, and its libraries were not designed to be purely immutable. And in some ways, trying to button on pure immutability is like trying to apply a lipstick to a pig. At the end of the day, you have a pig with lipstick on it, right? It's not of any use to anybody. Entity Framework is a great example of a library where immutability just sucks. You cannot do immutability with Entity Framework conveniently, or even I've never tried it. Maybe you can't do it at all. I've never tried. But I can see why, because Entity Framework under its hood wants to guarantee that a lot of the DB context things, a lot of the things that DB context can do under the hood is allow you to set values from one object to another, right? If Entity Framework wasn't able to do that, that would be really inconvenient. Entity Framework and mutability just don't get along. So, and it also really represents well the state of things like SQL Server, where SQL Server data is mutable. It just is. It's always been mutable. It's always going to be mutable. And many of us are going to program in SQL Server for the rest of our careers, which is great. Entity Framework just doesn't work. We use Entity Framework at my company. We use Entity Framework pretty much exclusively for data access, except for Dapper a lot in certain places where it's just more convenient. And if I told my team, I couldn't tell my team to just make all of our entity classes immutable. That wouldn't make any sense. You're really betraying what Entity Framework was meant to do. The bottom line is that EF depends on mutability. You cannot get rid of it. You cannot get around it. And so you cannot get around using mutability. But in your business code, you certainly can. You have that option. You can close those setters. You can make those services not null. And you can make it so that your business code, at the very least, does things in an immutable fashion. You can then take your Entity Framework classes and construct, using AutoMapper or something else, you can construct view models that can't be mutated down the road. The bottom line is that mutability is a tool. It's just a tool that should be sparingly used when we can avoid it. So let's go back to our original example, that bad code. And this is not going to be a very crazy refactor, right? We're just going to refactor that code just a little bit in order to get the thing done that we need to get done, which is, those requirements that were listed. So this is the code that we originally started out with. And then we went through a series of refactors where we gave it methods and we passed it and we started mutating those orders in place. But what if this data was immutable? And maybe it's not. But maybe you treat it as if it is. Maybe you think to yourself, I can treat this as immutable even if it actually is not. Again, our requirements being display negative orders in red, don't display inactive salespeople, and display calculated order commission, right? This is what we ended up with, and we can do better. So we can do something like this again. This is just, this is really a thought process change. To us, this is a very straightforward refactor. But it's not, again, about how straightforward it is. It's about changing our minds, changing our perspective to really say, well, instead of changing the data, I can just project it to something else. In this case, we've taken our orders and we've projected it to something equally as useful, but we've done it without actually modifying any code, or modifying the orders in place. Maybe the data is immutable, maybe it's not. But now we don't have to worry. We can worry less about bugs that come up from altering this orders because we're not altering it. And if we have even more complicated code that orders feeds into something else and goes and gets fed into other methods that it's doing things on, and it wants to guarantee, maybe it does need that salesperson to be there later, right? But maybe for this code in particular, all we want to do is just display the orders display the orders on this data grid. Maybe that's the point of this code. I don't know. It doesn't matter. The point is that instead of mutating the data in place, we've projected it to something that we can use. And of course, if you must write code like that, this is still better than mutating the data in place, right? If you must do it like this, by all means, I'm not going to judge you too hard. And it really goes down again. Well, look at part of the functional promise, right? How do we know that somebody does functional programming? They talk about how null sucks, and they talk about immutable data, and they talk about monads, whatever the hell those are. It doesn't really matter. The point is that we can take those lessons from functional programming. We can take the few of those lessons and apply them pragmatically to our .NET development. So our core takeaways from this should be to program defensively, right? You notice that not only did I close those setters, but I checked all of those incoming services inside of my order service. I checked it for null. Because I wanted to say, if it's not null, I want to guarantee that when I do things inside of this code, that this code those services are not going to be null. And I've done that by adding some logic to the constructor to throw exceptions anytime that I pass in a null object. If you're using a dependency injection framework, that should be cake. That should be super easy, right? Because your dependency injection framework will tell you if it can't construct something. And that's a lot clearer in instruction than getting a null reference exception at runtime, which is a terrible user experience. Program defensively, mutate sparingly, because mutation is part of the language. It just is, and it always will be. And avoid those setup methods and things especially methods where objects tend to be able to mutate themselves. They shouldn't be able to mutate themselves. Or at least if they do, they must do it in a predictable fashion. But one of those ways that you can avoid doing that is avoid those setup methods, as I mentioned. So close your eyes and imagine. You don't actually have to close your eyes, but imagine in a world if your objects never changed and your collections never changed, and if you avoided null, those things may not change, but you can change the world. Thank you very much. My name is Spencer Schneidenbach. If you have any questions for me, come and see me after the conference. As I always say, the conversation isn't done just because I leave this room. Hit me up on Twitter. Go to my website if you want to. I've got an email address. I have 100 different ways of contacting me. Actually, more like 4. But feel free to reach out to me anytime. My name is Spencer Schneidenbach. It's certainly a pleasure to talk to you, and thank you very much.